Hey everyone, so we are going to start talking about antiderivatives today. We spent a majority of first semester working on taking derivatives, right? And then we started looking at integrals, which is the area under the curve. Now we're going to start looking at being able to take antiderivatives, and then eventually we're going to start using those to evaluate integrals exactly. Before we dive into that, let's do a quick review of derivatives. So take a look at number 1, f of x equals x squared plus 3x plus 8. So you guys should be pros at this by now, and we can see that f of x is going to equal 2x plus 3. We know that the 8 is going to disappear since it's a constant, and we take the derivative, it's 0. Take a look at number 2. F of x is x squared plus 3x minus 100. So if I take the derivative there, I get f prime of x is equal to 2x plus 3. Well, now take a look at those two derivatives. You should be able to see right away that they're exactly the same. But if we look at the original functions, they are not exactly the same. This one was x squared plus 3x plus 8, and this one was x squared plus 3x minus 100. If you think about what those two graphs look like, they look drastically different. This one has a y-intercept at 8, this one has a y-intercept at negative 100. So we can see that clearly, even though their derivatives are exactly the same, the original functions are not. I want you guys to make a note really quick that for these two functions, f of x differs by a constant. But we still got the same first derivative, and that's because when we take the derivative of a constant, we know that that's 0, and so it goes away. This is going to be really important as we move forward looking at antiderivatives. So just real quick again, take a look at f of x is sine of x plus 8. The first derivative there is going to be the derivative of sine, which is cosine of x, and the derivative of 8 is 0. So f prime is simply just cosine of x. For number 4, we've got f of x is equal to sine of x minus 10. So the first derivative is simply just the cosine of x. Again, we can see that these constants here, although they were in the original functions, once we take the derivative, they have gone away because the derivative of a constant is always 0. So the big thing we really need to discuss here is what is an antiderivative and how do I find it? So an antiderivative is a term we use to describe the reverse process of taking a derivative. So usually we give you an original function and you find the first derivative, or the second or the third or whatever we ask you to find. Well, now we're going to be giving you the derivative, and we're going to be asking you to find the original function. So if we've got f of x equals x cubed plus 8, then we know the first derivative, or f prime, is simply 3x squared. So now we're going to start looking at the reverse of this. If f prime of x is equal to 3x squared, then the antiderivative of f of x means we need to undo this. The antiderivative is actually going to be x cubed, which that's good, that's the x cubed right there. But then the problem is we know nothing else about our original function based on this information. So we don't know what this number is, but we do know that there needs to be some type of acknowledgement that there was a constant there. So the way that we show that is by putting a plus c, and c just stands for any constant. Because now if I were to take the derivative of that, I would get 3x squared and then plus 0, which is what my function here was. Without knowing more information about my original function, I don't know what this constant value is, I just know that there's one there. So if you look at the review examples we did, we noticed that the constant term always disappears in the derivative. This is because the derivative of a constant is always 0. So we talked about that up here. Even though these original functions didn't look exactly the same, when we took the first derivative, the constant went away, and the derivatives ended up being the same. So this means we cannot determine the value of that constant just by looking at the derivative. So we write plus c as a placeholder for this unknown constant value. This is going to be super important as we move forward. So please make sure you've got that written down. So let's look at some of these rules for finding antiderivatives. I'm going to be honest, guys, this is why I kept giving you those memorization rules for the derivatives, right? I told you that this was coming. You have to know how to undo a derivative, which means you have to know how to take a derivative. So let's look at a couple of things here. Let's look at constant functions first. So constant functions really just mean that it's just a number, right? So if f prime of x is equal to k, some constant, then we know the antiderivative, or the original function f of x, is equal to that constant times x plus c. So for example, if f prime of x is equal to 8, then the antiderivative of that would simply be 8x plus c. If I were to take the derivative of f of x, I can check my answer and make sure that it actually works out the way that I'm thinking it's supposed to. So if I wanted to do a check, f prime, let's see. Well, the derivative of 8x is just 8, and the derivative of plus c is 0, which means I got back to my original first derivative here that I was given, so I know that this is right. Anytime you have a constant function, we just need to take it and turn it into a linear function. That slope that we got there is just the slope of the line. So that one should be pretty straightforward. For the second one, if we've got a polynomial, the thing I need you guys to think of is we're really just undoing the power rule. Because anytime we have a polynomial, to take the derivative, we just use the power rule. So doing an antiderivative means undoing the power rule. This is going to look a little funky. I need you guys to just bear with me as I talk through it, okay? So if the first derivative, or f prime, is equal to a times x to the n, then the antiderivative, f of x, is going to equal, well, let's think through this for a second. We know that when we're taking a derivative, we subtract 1 from the exponent, which means now I'm going to need to add 1 to the exponent, which means this is now going to become a to the n plus 1. We also know that when we're doing power rule, we usually take our exponent and multiply it in front. So since we already have this a, this is actually going to become a over n plus 1. And then we're going to have plus c at the end. So again, I want you guys to notice we started, our first derivative, had x to the n, which means the antiderivative needs to have this n plus 1 as the exponent. That also now needs to become the denominator of your constant, because otherwise, when we bring it down, it's not going to cancel out. So let's look at this example here. F prime of x is equal to 4x squared. So the antiderivative, f of x, I always start by looking at my exponents. So since I have x squared, I know that my antiderivative needs x to the third. I've got the 4 in front, so I'm going to put that in my numerator. And my new exponent is a 3. That means that needs to be the denominator of my constant, or of my coefficient, and then I need a plus c for my constant value. So again, you'll notice this x to the n plus 1, here's my new exponent, it's a 3, which means I need a 3 down here so that when I take the derivative, I'm just left with a 4. Again, we can check our answer here. So if I wanted to check this and take the derivative of f prime of x, if I drop the 3, I'd have 4 over 3 times 3. That's just going to give me 4, and then x squared. And the plus c, of course, cancels out since that's 0. So you can always just take the derivative to check your answer. Okay, powers of -1. This one is super, super important. This is not undoing the power rule. So you cannot undo the power rule. when it's powers of -1. All right, powers of -1 means something like this. F prime of x is equal to 1 over x. So what a lot of students end up wanting to do is they say, okay, well, 1 over x is equal to x to the negative first. So if I'm going to undo the power rule, I'm going to add 1 to my exponent. That becomes x to the power of 0. And then my numbers in front become 1 over 0. And hopefully you guys look at that and you can immediately tell that that's a problem. We cannot use the power rule to try and undo a power of -1. You should be able to look at this and recognize that that is the derivative of the natural log of x. So anytime you have 1 over x, the antiderivative is the natural log of the absolute value of x plus c. So f prime of x is equal to 3 over x. The first thing I want to do is I want to point out to you guys that this is the same as 3 times 1 over x. So when we take the antiderivative and find f of x, the 3 really just kind of tags along in front, and we can see that the antiderivative of 1 over x is the natural log of the absolute value of x, and then we need our plus c for our constant. This is probably going to be the biggest thing that everybody gets tripped up on. Anytime it's a power of -1, it's got to be a natural log for your antiderivative. Okay, and then here is all of our normal derivative rules, but now we're doing antiderivatives. This is why knowing those rules is so important, you guys. So I'm going to race through these because this is just going to be a matter of you being able to memorize this stuff. So bear with me, follow along, and pause if you need to, okay? So if I have f prime of x is equal to sine of x, then the antiderivative, which is f of x, is going to be the negative cosine of x plus c. If I take the derivative of negative cosine, that will get me back to sine. So make sure you are always very careful with your signs for sine and cosine when you're doing derivatives and antiderivatives. If my first derivative is a positive sign, that means the original function was a negative cosine. If my first derivative is cosine, then the antiderivative, or the original function, f of x, is going to be sine of x plus c. F prime of x is secant squared x. Hopefully you recognize that as tangent of x plus c. First derivative is secant x times tangent of x. The original function f of x is going to be secant of x plus c. If the first derivative is cosecant x cotangent x, we need to be careful because that should have originally been a negative cosecant x cotangent x, which means when we take the antiderivative, it's going to be negative cosecant of x plus c. And here we've got the first derivative is cosecant squared. Again, that's one that's usually negative, which means my original function, which is cotangent, must be negative in order to make our first derivative positive. So again, be very careful with the signs on ones like this, this, and this. For the next ones, we've got exponential and logarithmic functions. So this first one should be super easy. F prime of x is equal to e to the x. Then the antiderivative, or the original function, is really just e to the x plus c. That should always be one that you guys are super excited to see because that is the easiest one. E to the x is always just e to the x. This one we talked about already. F prime of x is 1 over x. So the antiderivative, f of x, is going to be the natural log of the absolute value of x plus c. These two are a little bit trickier, but you have to know your derivatives of logs and exponents in order to be able to get your antiderivatives. So if we're looking at the first derivative being 3 to the x, then our antiderivative, f of x, is equal to 3 to the x over the natural log of 3 plus c. Really, in order to figure this one out, you really have to know that original derivative rule. I'm going to show you guys, I want to check this out real fast and actually take that derivative and make sure it's correct. So if f of x is equal to, I'm going to rewrite this as 1 over the natural log of 3 times 3 to the x plus c. If I take the derivative of that, then I know that 1 over the natural log of 3 is just a constant, it's just a number. And then times, let's see, the derivative of 3 to the x is itself, so 3 to the x, times the natural log of the base, which is 3. And then we have plus 0 for that plus c. The natural log of 3 cancels, and I get that my first derivative is just 3 to the x. So there it is. I know that when I have an exponential function, the natural log of the base must be somewhere in my antiderivative. Since it wasn't, I needed to divide by the natural log of 3, since that was my base. I know that's a little confusing, so if you've got questions on it, please make sure you make a note and we'll talk about it in class. This one should look fairly familiar. This is f of x equals log base 3 of x and then plus c. So anytime you've got 1 over x with a natural log of a number, that is the original function is log base whatever that natural log is. All right, then we got the trig inverse, or the inverse trig functions. So again, you guys, if you know your rules, it's easy. If you don't, then you gotta learn them. So I'm gonna race through these ones real fast because I want to get to our example that we have to do. So 1 over the square root of 1 minus x squared, you should recognize that as sine inverse of x. Oops, sine inverse of x plus c. Over here, all we have is the opposite of that derivative, which means this original function is cosine inverse of x plus c. 1 over 1 plus x squared, we would get an original function of tangent inverse of x plus c. Over here we have just the opposite of that, which means this original function must have been cotangent inverse of x. And then we've got 1 over the absolute value of the square root of x squared minus 1. So this original function is secant inverse of x plus c. And since this one is the negative of this, this must be the cofunction. So it must be cosecant inverse of x plus c. Again, you've got to be able to recognize these rules. So if you've got your old flashcards, I really suggest taking them out and trying to memorize all your stuff again. All right, so let's see. Find the antiderivative of the following function, and we're going to check ourselves over here. So we're going to start with this piece first. So f of x equals, let's see. I need the antiderivative of 3e to the x. So I'm lucky, that's actually just 3e to the x. That one's nice and easy. And then I have this minus 5x to the 1/2. Although it's not a polynomial, I am still just undoing power rule. So I'm going to have my minus 5 for sure. And then I have my x. It was to the 1/2 power. I need to add 1 to that. So that's going to be 3/2. And I know that I need some number in front to be able to cancel the 3/2 when I drop it down. That means I need a 2/3 in front. So it's 2/3 times 5, x to the 3/2. And then I've got this plus 1/2 secant squared of x. So you should recognize that. The 1/2 just chills. But secant squared of x, the antiderivative would be the tangent of x. And then finally we've got this minus 1 over 1 plus x squared. So the antiderivative of that is going to be plus cotangent inverse of x. And then we have to remember that we need our plus c all the way at the end. So now let's go ahead and just simplify this really quick. So we're going to have f of x equals 3e to the x minus 10 over 3 x to the 3 halves plus 1/2 tangent of x plus the cotangent inverse of x plus c. So this is our final answer here. And we can use this space over here to check ourselves, but this video is getting a little long, so we'll do that in class tomorrow as a warm-up, and you can see exactly that we get back to this original function. All right, if you have questions, please make sure you wrote them down. We will talk about it in class. Thanks.